For the last video in section 3.1, I wanted to draw your attention to this nice little summary from the textbook or e-text. This is from page 104, but I thought they put it fairly nicely here. This is really hitting home this idea that the same calculation can cover some different wordings in calculus here. So the calculation that we're looking at is this limit of the difference quotient. Okay, right here, limit as h approaches 0, f of x naught plus h minus f of x naught over h. So we have been using that for the slope of a tangent line. And there it is right there. So the slope of the tangent line, you can calculate that by using this limit of the difference quotient. So the slope of the tangent line to the curve y equals f of x at the point x equals x naught. Now, in chapter 2, they also used the phrase the slope of the graph or the slope of the curve. So this could say graph or curve there. So the slope of the curve or the slope of the graph is the same thing as the slope of the tangent line at that point. Because what is the slope of a curve at a particular point? Well, it would be the slope of whatever line is touching the curve at that point, which would be the tangent line. So that's why 1 and 2 mean the same thing, and you calculate them in the same way. So slope of the tangent line, slope of the graph, slope of the curve. Okay. Now we've also seen that the slope of a tangent line can be used to represent a rate of change. And specifically, this is an instantaneous rate of change. So that's number 3 on the list here. The rate of change of f of x with respect to x, we'll get into that with a little more detail. Basically, with respect to x means that x is the thing that's changing. But the rate of change of our function with respect to x at this particular point, x equals x naught. So that, let me just note for us, this is an instantaneous rate of change because it's just at that particular point. X equals x naught. So instantaneous rate of change. This is not an average because there's not 2 points to look at. There's just one, so instantaneous rate of change. And then number 4 here, this is what we got in section 3.1. So the first 3 of these really came from chapter 2. And then here in 3.1, we discovered that all of those use the same calculation as the derivative f prime of x naught. So when you see any one of those phrases in a problem, you can calculate any one of them with the difference quotient. Or we'll learn some other tricks a little later on in this chapter for calculating the derivative. There are some faster ways to do this. And then you can use those calculations to help you find any one of these previous 3 statements. So all 4 of these things really are tied together. So just keep that in mind as we're moving through the rest of the class.